Hi, Science and Cooking. This is the TF Steve, and I am going to work through a problem from the elasticity piece set with you right now. Specifically, problem number 5. So in problem number 5, we are asked to see what the elasticity of a piece of steak is for both a cooked and uncooked steak. I'll just work through the uncooked steak. First question to ask yourself every time you attempt to do a problem for this class would be what equation you're going to use to do that problem. In this case, it's not too difficult of a decision because there's only one equation of the week. This one, elasticity equals stress over strain. Or stress expressed as force per area, strain expressed as change in length over a reference length. I recommend when working this problem to compute both the stress and strain independently and then put them together to make the elasticity. So let's look at the problem. Someone has grilled a steak, or actually before they grilled it, they have not grilled it, so it's uncooked. And they're applying a force of 5 newtons over an area of 5 centimeters squared. So in this case, that's the stress. That's the force that's applied to an object. So let's solve for that. Stress is force over area. And the units that are recommended in the problem set are force in newtons and area in meters squared. So we're given a force in newtons, 5 newtons, which is great. We're given an area in centimeters squared, which is not the same thing as meters squared. The first thing I need to do is note that I have the correct units on force, but I do not have the correct units on area, 5 centimeters squared. How do I change that into the units that I need, which are meters squared? Well, there's this really handy thing called a unit conversion, which is really an essential skill for working science problem sets. So, based on the fact that I know that there's 1 meter per 100 centimeters, I can actually apply this knowledge to figure out how many centimeters squared there are in 1 meter squared, which are both measures of area. And it's really just as easy as taking this unit conversion, 1 meter per 100 centimeters, and squaring it. If I do that, 1 squared is 1 times 1 is just 1. And a meter squared is a meter squared. And on the bottom, 100 squared is 10,000, or 10 to the 4th power. And a centimeter squared is a centimeter squared. So here I have a unit conversion that will take me from centimeters squared to meters squared. The wonderful T.F. Gregg has reminded me that unit conversions can be thought of as multiplying by 1. So if 1 meter squared and 10,000 centimeters squared are the same thing, then this fraction has the same thing on the top and the bottom and is equal to 1. You can always multiply something by 1. So if I take my area of 5 centimeters squared, multiply it by 1 in the form of this unit conversion, I will wind up with this number right here. You should confirm this on your calculator. Just take a second. 5 times 10 to the negative 4th. And this cancels with this, because this would be on the top of a fraction and this would be on the bottom. So we're left with the units that we want, meters squared, and we have our area in the correct units. I'm now in a position to go back and calculate that stress. So I have the correct units. So it's 5 newtons over 5 times 10 to the 4th meters squared, or negative 4th meters squared, excuse me. So and do this along with me. Calculator usage, very important for this class. You should get this number here, 10,000 newtons per meter squared, which is the same thing as 10,000 pascals, because a newton per meter squared is the same thing as a pascal. So we're done with the first part. We've computed stress. We now have to compute strain. I'm just going to put a little circle around that, so remember where that was. Okay, strain, in this case, not quite so complicated. For the uncooked steak, the strain is the deformation over the initial length. The uncooked steak is compressed by 7 millimeters. That's the deformation, the change in length. And the original thickness of the steak was 25 millimeters. So that would be our reference length, our L. Doing this division here, 7 divided by 25, gives us 0.28. Millimeters divided by millimeters just cancels, so the strain is actually unitless. There's no units to worry about there. It's wonderful. Now we have stress over strain, and we can simply calculate our elasticity. (10,000 pascals) divided by 0.28. You should arrive at a value of 35,700, roughly, pascals. And that's it. Okay. Stay tuned for part B.